Hello everyone. It's my honor to introduce our group members and our group presentation. Today is Minjie Han and me, Haoran O, to do this presentation, and our group member is Haoran O, Minjie Han, Ke Qiu, Qixuan Gao, and Ke Yizhong. So for the first question, what are the new and alternative hypotheses that the project 2 is testing? We think that the null hypotheses are those where the return is zero. That is, the long to short-term portfolio has no significant return. So the alternative hypotheses are those where the return is not zero. That is, there is a significant return. So what's the methodology of the portfolio structure and how is it implemented in the Project 2 code base? First of all, we think that the methodology of the portfolio construction is a long to short portfolio. This is an investment strategy. It starts by sorting asset prices by volatility, and after grouping them, we divide them into shares that end in months. The return of the long to short portfolio is calculated by subtracting the yearly and monthly weighted return of the first quartile from the yearly and monthly weighted return of the last quartile. We can find that the purpose of this is to get a defined return from the change in the asset price. And how is it implemented Project 2 code? In order to build a long to short portfolio, we can divide it into 3 steps. The first step is we do extract, transform, load, and encode. The second step is to calculate the volatility. And finally, the third step is to build a long to short portfolio based on the results. So here is how we did it. The extract and transform data mainly transform the stock data to meet the machine's needs for analysis, and then add it to the return dictionary in our project for analysis. In analyzing the CSV file of several information about the stock, we use the read PRC CSV function, which mainly helps us to take the closing of the specific stock ticker with the specified date range. So for the calculation of stock volatility, the VOL code function is used in the code. When we set the parameter CHA name into 4, the standard deviation of the daily closing price from the result of ETL, which stands for the extracted transform data, is used to get the calculated monthly volatility. The monthly volatility calculated in the previous step is then merged in the monthly return using merge tables. The volatility is calculated by analyzing the past price movements of stock. Calculating historical volatility usually involves deriving the standard deviation of price returns and possibly adjusting the monthly to analyze the volatility as needed. So for the building a long to short portfolio, it is constructed by going along the past quartile of the stocks and short the first quartile of stocks each month. The steps in the code are divide the stocks into 9 quartiles so that we can rank them. And each stock is assigned a rank in its quartile based on the aging values. This is done using stock sorting, and then based on the grouping, we construct a long to short portfolio by going along the last quartile and short the first quartile of stocks each month. The process of calculating the return is done by the PF code function, which calculates the monthly return of the long to short portfolio. So let's move on to the third part. what inferences can draw on the output of part 9, including the average return and t-statistic of the long to short portfolio. So firstly, is bar is the average daily return of the long to short portfolio strategy over the entire sample period. It can be used to measure the performance of the strategy as a whole. If this value is high, it means that the strategy as a whole is profitable. Conversely, if this value is low or even negative, it means that the strategy as a whole is underperforming. Secondly, the AST is the result of the calculation of the t-statistic, which is used to test whether the average daily return of this is significantly not equal to 0. Specifically, by calculating the t-statistic, we can determine whether the observed returns are statistically significant. So when the value of the t-statistic is greater than plus 1.96 or less than minus 1.96, we can reject the null hypothesis. For example, we consider the average daily returns of his text to be equal to 0. Which means that we have sufficient statistical evidence to prove that the A's portfolio does have the significant returns. Conversely, if the value of the t-statistic is between minus 1.96 and plus 1.96, we are unable to reject the null hypothesis, suggesting that there is insufficient evidence to prove that its portfolio has a significantly non-zero return. So there is no statistically significant difference in the performance of the strategy difference and may imply the result of random fluctuation. The result in the demo is less than 1.96, so we cannot reject the null hypothesis, which suggests that we do not observe a significant gain. That is why the strategy may have some fluctuation over the sample period. These fluctuations are not enough to prove that the strategy is significantly profitable. In this case, it may be necessary to further optimize the strategy or adjust the parameters to obtain better results. Now let's invite our Mingjie Han to introduce the fourth part.
Hi, Professor. My name is Mingjie, and I will finish the next part. See this part, and do you think the results are reliable? Why and why not? And my answer is I do not think it's 100% reliable, and there are always reasons why data results are unreliable. First one, the reason the reliability of the result depends on the quality of the data used. If the data is incorrect, missing, or just incomplete, this can greatly affect the analysis and make the result less readable. And the other result is the portfolio structure. Use a simple approach to the pollution structure. For example, use only volatility. May ignore another important factors that account the market performance. And since marketings are conflicts and rely on volatility alone may lead to the poor result. And they also have some other factors. It is also important to consider the fairness of the choosing model and whether it takes into account the reality of the training, such as transaction cost and the market. These factors are greatly affect how strategy performed in practice. And we can see the last part. Is there any further work you would like to pursue besides on project 2? And I want to share you uh, there is still a lot of work I would like to do, and the main purpose of this work is to deal with possible unreliable in this resource and to make the overall results more reliable. And the first is to extend the time form. Takes the stretch over different time perform to see how it's perform under so much kinds of market conditions, and this will help determine if the solution is setable in different market. And the second is to try two or more combinations. Combine the valid strategy with other types of strategy, such as the trend following or mean reservation. And the last result is the last we want to collect more market data. Depending on the solution, future research could include some more marketing structure, consider market, and to analyze some economic data. And this is our main presentation, and this is all. Thank you, Professor.